Welcome everybody to another series in our CPD in 43. This is our event for May. This is brought to you from Eugene Korch from Eugene Korch & Co. This would be 3D detailing and analysis of contemporary brick facades, a really interesting analysis, and I don't know whether anyone attended a previous talk that he did. It was extremely interesting, and I'm sure this will be even more interesting. So I won't keep you any longer. Naturally, I'm here. I do encourage people to comment into the chat box, and we can field that during our Q&A session towards the end. And we will also highlight our future events towards the end of the talk. But without further ado, I will hand it straight over to Eugene, and I hope you all enjoy the talk.
Hello, everyone. I assume that you all see my screen, and we're going to be talking about brick facades today. Brick is very popular. It's what we see all around us. Very popular material for facade. Probably is the most popular for the material in the UK, and it gains, even more. It becomes even more popular going forward. However, not all the brick facades are masonry facades. Predominantly, so more methods of construction have different ways of achieving a facade. Today, we are going to be looking mostly at this bay, and we'll be the one that you see on your screens right now. This bay, and we are going to achieve it in 3 different assembly methods to achieve that look in different assembly methods. Namely, it is masonry veneer, brick slips, and precast. And we're going to conclude with the case study, which has a mixture of all 3 of these facades. There'll be no drawings, there will be no text on the screen, just 3D details the way we like it, and just some verbal narrative to it. Okay, so these 3 types of construction, of method of construction, would be what we'll be talking about today. They're all modern. It is masonry veneer, brick slips cladding, and precast concrete facade. These are the 3 most common ways of achieving the same look in the buildings that have a brick outlook. And so we're going to start with just looking at these 3 options and achieving that bay in these 3 options. If you look at these 3 3D details, they will be looking very, very similar one to another. Hold on, I'm just gonna mute my screen so I don't hear the people joining the conversation. So this is masonry, this is brick slip, and there's precast. You don't see much on the outlook on the details that you can see on the screen right now. However, if we're going to do this slightly exploded view of these 3 details, you would understand that they're actually assembled in different ways, and the philosophy of assembly is entirely different. Masonry, or modern traditional masonry, relies on dead loading the brick at the every slab level or every other slab level on the shelf angle, and the bricks are stacked one on top of another and tied back with the bricks and brick channels to the backing surface. Whereas the brick slip is more of a rain screen cladding. It is a rain screen cladding. Mostly has help me hand brackets, rails, counter rails, and brick slips fixed to this assembly. Precast concrete assembly has the brick slips cast into the precast concrete panels, and these are installed on the primary framework. Where to use which system is probably the main topic of this conversation. So because they are virtually achieving the same look, probably brick would have some movement joints, and precast concrete would have even more visible joints, whereas the brick slips would have more of a kind of a homogeneous look. But it's far more complex than that. Just the outlook. The main parameters for that would be the height of the building, fenestration layout, a brick pattern or bond, as well as thickness of the wall in relation to its thermal performance, and availability and quality of labor and skills available at the region of whether the project is. Now, most common, probably, I'm not involved in that kind of buildings that much, but you know, it is a low-rise building, where the primary framework is a timber frame, and the outer layer is brick, and it's traditional brick masonry. And for these buildings, it really makes sense to have it a masonry veneer building, as predominantly the main element here is availability of labor. In the UK, labor is available for these type of buildings, and there is no rush to get a scaffold up because it's only 2 floors or 3 floors. For the low-rise building below 18 meters, or probably it's going to be 11 meters soon, this is the way to go to achieve a brick facade. This is the cheapest way. There is no shortage of labor comparatively to, let's say, precast or unitized brick slips. So that's what is the most common way. Where the saving here is, or the why this is so cost effective, is it is dead load at the very bottom of the building, and the foundation of the building also can serve as a dead load element to receive the facade. Whereas, so we can have a we can have some kind of an upstand for, or just a part of foundation to where the brick is stacked on, and it's laterally loaded on the primary framework, which in our case is a timber. Things get a little bit more complicated when the building becomes taller. And if we want to stick to the to maintain the same masonry stack effect, we are using shelf angles at every other slab or at every slab, depending on the fenestration and the bond of the brick. And here we actually start touching one of the main parameters. What is the fenestration of the building, how the windows are arranged, and what is the pattern, how the bricks are arranged. This will be one of the key parameters to choose how we are going to achieve a brick system, how we're going to achieve the outlook of the brick facade, whether it's going to be the masonry, veneer, brick slips, or precast. This building, this outlook over here, could be achieved with not traditional, with the masonry veneer, with the shelf angle. However, the shelf angle will have to be installed at every floor, not at every other floor or in what we've seen before on the very bottom of the building, because of the complex pattern where the bricks are recessed in and out. The windows are quite large, quite wide, and the brick pattern itself is different. There's a different in different places. So here we have a vertical stack bond, and we have to install it like that. So in order to tie them together, we need to add additional, and I'll zoom in here so you can see slightly better. So we need to add additional ties and the additional wires to tie it all together. Here we have slightly recessed horizontal stack brick, and in order to accommodate that, we need to also get horizontal ties, and the centers of the studs would be far shorter than if that would be a more kind of conventional stretcher bond. So this assembly becomes somewhat expensive to achieve that outlook. So these 3 details will kind of show what support that brick would require. And for these kind of types of facade, where the fenestration is not, when the windows are not stacked and the brick bond is not stretcher bond, it's really worth considering having, for tall buildings, to have brick slip accommodation, a brick slip facade instead of masonry. So how does it, for example, this building here has a stacked window, and again, one of the parameters. If you see on a building, if you're looking at a building and the windows are not one underneath another, they are staggered, the locating masonry support and having different precast elements here would be for not cost effective, and B, that would create some challenges with fire compartmentation, because you need to maintain within one compartment forming element here, which is a slab. You need to fit in that area. You need to fit the masonry support and the cavity closer. So all things considered, it's worth looking at brick slips for the buildings where the fenestration is a little bit more complex than just windows stacked on top of another, and when there's a brick bond that is not stretcher bond. It's worth looking at having that in brick slips rain screen facade. In this case here, we do not need to necessarily to have this downstand here to fit the masonry support. We are treating this as a normal rain screen, and we have brackets and rails, brackets and vertical rails running the way we want to, and we can achieve virtually any pattern. It doesn't matter for us that much what kind of pattern we are going to use for brick, because most of the systems can accommodate. It doesn't matter for brick slip system to have vertical stretched board or horizontal stretching bond. It will not have that significant impact as it would have an impact on a more of a traditional masonry support. So then we have to look at having a brick slips for our building. So here is the comparison of the two, where we can see that we no longer need to have all this complex assembly, and everything is pretty much sorted with the traditional rain screen element. Now, it's also this slide here. I put this slide here is just to mention that brick slips also is worth considering for a low-rise building, not necessarily for where the different bonds could be an issue, and for where the ratio for thickness of the wall and its thermal performance could be an issue, because not necessarily for that particular building, but right, I'll just rephrase it a little bit here. So for low-rise buildings, brick slips could be considered, could be a good option to save on the thickness to thermal performance ratio if there's an opportunity to use high performance insulation, not necessarily mineral wool, but PIR or PUR insulation for more lightweight elements, and with the timber subframe. That's also worth considering for systems that are not necessarily non-combustible. So for buildings below 11 meters, using a brick slip system that are relying on bonding brick slips could be an option. This, however, is not recommended and probably not even viable for building taller than 18 meters or 11 meters. So for brick slips are considered for buildings that are much taller than 3-story height. That brings us to the high rises, because we looked at the mid-rise buildings that are brick slips, but for high rises, it's really not a good idea to use masonry cladding, masonry veneer for high rises. And the main element here is the access. It requires scaffold or for masonry, and for brick slips it definitely requires at least a mast climber to install it. So for the high rises with the brick finish, it is recommended to use unitized rain screen brick slips assembly, similar to what you see what you see here. The restrictions here are there are two restrictions here. First, we are going to have a lot of joints because units are usually to have them cost effective, they would be no more than, let's say, 2.5 meters wide, and they would have to go floor to floor. So we are going to have definitely a lot of joints, for visible joints for a unitized assembly. These joints would be very visible. So that's one of the things to consider. Sorry, that's something that happened there. That's not really that seen in that render. And the reason for that is when there's a high-rise building with a brick facade, it's going to end up being either precast concrete or unitized. And it is really good idea to design that building with having a lot of joints in mind, and in order to conceal them, the fenestration should take that into account, and protrusions and recesses could actually hide that. Which brings us to the precast concrete assembly. It's the third way of achieving that outlook. And we start with the fully prefabricated precast concrete building. This facade assembly, it's not a facade assembly, it's just the entire building is precast, and you can see that the external wall is load-bearing. Effectively, this becomes a panel, a sandwich panel, with a corbel in here, and that also can receive the floor slab. This is very common for, let's say, student accommodation buildings, predominantly in Europe. There's a lot of them built like that. In that case, we have outer veneer concrete, outer leaf of concrete, to which we can cast in brick slips. And in that case, you can see here, there's a lot of recesses and protrusions and different color of the brick used. All of that was in that building to conceal the panelized nature of the building. You're still going to see the joints in here, but they will not be that as visible as you would say in the unitized facade. And again, you don't see all these joints in the corners and between the recesses, because when in the corners, the joint becomes automatically concealed. That's when the building is fully prefabricated. But there is another way of getting a precast concrete facade, and we're going back to the building we just looked at. We also can achieve our case study in the precast concrete, the one we started the talk with. And we can straight away see that we actually getting all these joints visible, and it's becomes a more kind of panelized nature. You can dust these joints in the mortar, you can color match them, but they will still be a little bit more visible than the joint between the two bricks. It's something to have in mind when the precast concrete building is designed. So what we have in the precast concrete building. Precast concrete facade. It's not a building, it's a precast concrete facade. In here, the building is the same. It can be a primary frame, or it can be steel structure, or primary precast or in situ concrete frame. And the precast concrete panels are fixed to it as a prefabricated facade. And again, we have. I'm not going to talk much about how this system works with the drainage and everything else. I just want to focus on how to achieve a brick veneer here and what to know about it. So again, we don't care straight away when we're using the precast concrete building. It is very forgiving for brick bond. So we can have normal stretcher bond, we can have a vertical stack bond, we can have horizontal stack bond. All of that does not matter and doesn't have any effect on the performance of the precast concrete facade. It's just a veneer wrapped around the precast concrete panel. So it's probably the most forgiving way of achieving a brick outlook with a complex pattern is the precast concrete, because you can arrange these brick slips in circles and that will be fine. So one of the things here to bear in mind is that it has to be very, very repetitive, and it has to be a lot of it. There's the precast concrete facade would not be cost effective for a low-rise building and not for every mid-rise building that would not have enough repetition, because precast concrete contractors would want to create one mold. Oh, sorry, I'm just. They would want to create one mold and would like to repeat it as many times as possible, and that's how they make the money, and that's how the big project becomes viable. And you can achieve the vertical stretcher bond, as in this case here. So yeah, that's one thing to bear in mind. So vertical stretcher bond is, or any kind of bond, you can get the fish bond, you can get them, you know, you can get creative with that. So precast concrete, and we're going to be talking about in the last part of the building, which is of the talk here. So vertical stretcher bond would be prohibitively expensive if we are to achieve this protrusion in traditional masonry. In traditional masonry, this a shelf angle out of stainless steel and the fire implementation goods to deal with the hollow features here would be really expensive. And when we have a lot of geometry on the project, and when we have a lot of complex brick patterns, it's really worth considering precast concrete as a facade. Another thing to consider here for these buildings, and we can go here again, there also is important to have a solid wall to vision wall ratio right. Precast concrete contractor would want to have a certain amount of distance between the window, they would want to have a certain amount of meat between the windows to get the structural integrity of these precast concrete panel donuts, because they are craned in the position, and there should be at least, let's say, 5 courses of brick between the windows in order to make sure that this is structurally sound and can achieve long panels, and and forms and molds that are easy to replicate. There's a third way of achieving a precast concrete panel, precast concrete facade, and where it could be useful. For example, and again, that goes against everything I just said about we don't have enough meat, as I would say, between the windows. So that distance here would be really, really kind of small. We will not be able to get 2 panels, I could say, if we just try to panelize that. We would not be able to achieve a panel that would do all these joints like that. So that would be very difficult to achieve, to fit the corbels and the brackets and the ties to get that precast panel working. In that case, sorry, why does it do it? In that case, what usually tends to happen is that the precast is installed separately to the windows. So the first the precast concrete elements gets installed separately to the windows. So that would not be the panel as we've seen in the previous element. It would not be split. This would be beams and columns that are purely decorative, and they are there just to receive the complex brick pattern with protrusions and recesses. So that's purely decorative, and they don't serve any other purpose other than the decorative element here. So for that element, and as I said at the very beginning, this is also sometimes could be achieved with the simple GFRC elements, not necessarily entirely precast concrete, but this particular case study, it is precast concrete beams and columns, and the windows would be installed retrospectively. So once the whole frame is installed. In this case, is precast elements, precast brick is worth considering for where you have really complex, onerous patterns that need to be achieved off-site. That could be in a control condition. You can get that done and bring this element to site, and still require to have external access to complete the building and to make the facade watertight and install insulation and do other measures. Now, I just add this slide here for one simple reason. Sometimes a parameter would be that you can get complex pattern like this one. However, you can't achieve it as a precast because you cannot get hit and miss brick with a precast concrete element, as you can't cast into the thin air. You would still need to rely on stacking bricks on top of another. And even though this facade bay looks repetitive, the windows stacked one on top of another, yet we still have hit and miss brick as a solar shading on this particular case study. And that actually drives the project to be masonry veneer with brick support at every floor. There's a requirement to have a downstand to accommodate the shelf angles and the cavity closers, and to accommodate the hit and miss stack brick with that also serves as the solar shading and potentially ventilation. So sometimes all of what I said before about patterns and complex assemblies and different bonds could be completely overwritten by having a hit and miss brick. So we have to be careful about that. However, there are projects when a combination of all of these elements would be required to achieve the brick outlook for the high rise that would not be either not cost effective or onerous or not possible to achieve in any of those bricks methods of assembly on their own for various reasons. And this is the case study that shows exactly that. What we have here, we have a precast concrete assembly with the windows fixed to it, but because we have a very thin walls requirements, well, we still need to get the recess. We have a brick slips here, and in order to achieve the a certain fenestration, where we have a slit windows, we will have to use unitized facade with the brick slip fixed to it. And let's discuss how we got here. So here is your donut, and as I said previously, precast donut that received the window, and it requires some amount of, as I called it, meat to achieve the to get the structural integrity and to be able to be craned in the position. In our case, is 1.5 brick here and 4 bricks in height. And this pretty much virtually is the minimum what you can do in brick and precast. But we need to get the recess here, and that is flush with the window, hypothetically. And in order to achieve that, that window is installed with the brick slips fixed to it, as you would as a brick slip assembly here. So you will have a window frame, but instead of the glass, you would glaze in a certain metal frame that would then receive a brick slips as you would mechanically fixed brick slips, non-combustible, to be installed to the precast unit. Then that would be craned into the position installed as the precast unit. So we have a hybrid of precast and brick slip assembly in one location. In certain areas, that would be installed with a precast bracket and a tie, as we see here. But to achieve a certain fenestration outlook, we would also need, and to avoid the requirement for access from the outside, one would also use a unitized facade assembly in some locations, like we see on the details here. So that particular project has all 3 assemblies together to achieve a certain look, and in that case, it would require 2 different contractors to do that. So that is effectively what I wanted to discuss here within this half-an-hour talk. Again, I would like to stress that one of the most important things that we need to consider as we are designing the brick facade is first how tall it is. For low-rise buildings, we are looking pretty much always at masonry veneer facade. For mid-rise, we are looking at brick slips or masonry veneer facade, or we are looking at precast concrete if it's very repetitive and it's high-rise, or if it's really complex brick pattern. And if it is really high rise, if it's a skyscraper and it still requires to have a brick veneer to it, one would need to consider unitized assembly with the brick slips fixed to it. So I would assume that I would conclude with this, and I will, if you have any questions on the presentation, I will be happy to answer those.
Thank you, Eugene. That was great as usual. We do have some questions that have come in, but please do, everyone in attendance, please do make sure you field your questions whilst we have Eugene on the call. We have a question in from Joe Stewart where he's queried the specification of the white brick slips on your detail here, whether you have the product data sheet, etc. What specific item is that, or is it more representative?
Brick slips, I would, because I'm not representing anyone or anything here, I'm just purely sharing my experience and not selling anything. I would say that there are 3 brick slip systems that I'm familiar with, and they can achieve that particular look, and they will be non-combustible, they will be mechanically fixed, and they will have all relevant certifications to my knowledge. There will be mesh clip by Ipstock and Nash and Lacey. That will be Corium by Telemax, and that will be the last one, be Stolfix. I'm not sure who is the distributor of that material is right now. I need to check that. All of them I worked with, and they would be compliant to a certain degree. One thing that I need to stress here is, for example, Corium brake slip would not be able to match, not be able to achieve some of the natural brick looks, because it's a terracotta tile. Effectively, it's a ceramic tile extrusion. Whereas the other 2 would be able to achieve most of the outlook. However, I personally really like Corium for its engineered way of installation, and I think it's probably the oldest in the market, has all the relevant certification. So these 3 systems, if you are in the UK and this stock is is covered in the UK, I would assume these 3 that I'm familiar with, and I would say that it should be more or less safe to use these 3.
Thank you so much. We've got a question in from Liz. What would the standards for testing the performance integrity of the brick precast concrete panels be?
There is a standard brick, standard precast concrete BS normative, which I don't remember off the top of my head, and it has all the parameters for how the joints are drained and how they're installed, and also prescribes, there's a British standard for that, prescribes how the bricks have to be cast in and what kind of weather performance test. I think it's cube test, when there's freeze thaw test, when they take the cube of precast concrete and they freeze and thaw it for X amount of time. Life cycle test, sorry, that's how it's called. So there's a British standard for precast concrete, and it covers any cast elements such as terracotta, stone, and brick slips cast into the precast, and it should cover you for most of the projects. But there is always facade engineers' performance specification on the high-rise buildings. It tends to be that could prescribe more onerous tests. or for example, for as on the building that was this one, because it's like not as a really standard precast concrete arrangement. It's got all the elements. There was CWCT sequence B test carried out for that particular assembly, because it's, you know, it is a bit of a bespoke thing. So to summarize, there's a British standard for it that I need to Google exactly the name, or in absence of it, CWCT sequence B test for complex arrangements, and yeah, facade performance specification for high-rise building or complex facades.
Thank you. We've got a question in from Osman. Which of these solutions presented has the highest embodied carbon as a whole wall buildup?
I'm not really good with sustainability in carbon footprint, but I would assume precast concrete would be the highest. Concrete is not really a necessarily sustainable solution. I would assume that the most, and I guess this one, the low-rise building that has this arrangement, and I think that was the one of the, you know, this is Briam building, because a timber frame and the brick veneer is used on the outside. So this is the least amount of carbon, I would assume. I'm not really a specialist in that. That would be the best way of achieving the brick facade, and the most cost effective and the most sustainable way is a low-rise building. It's low-rise timber frame, not using metal to support as much as any other one would be. So low-rise masonry veneer, timber frame, that would be the the best carbon neutral, not neutral, but carbon the best, the more sustainable way of installing it. I must apologize here, because I'm a facade engineer from a very pragmatic approach to achieve the building, and usually that's something that I'm not getting involved in. It usually happens at the much earlier stages of the design work. I'm dealing with how to achieve a certain outlook when all the deadlines are passed, and you know, the decisions have to be made based on the cost rather than a carbon footprint.
Okay,
So,
thank you. We've got a question in from Jonathan. Is it possible to achieve a frameless window appearance from the outside so that you don't see the window frames when looking at the building?
with brick? Can you repeat the question again? I didn't get it.
No worries. Is it possible to achieve a frameless window appearance from the outside?
With brick, yes. Yes, it is possible. I would say it would come at the cost. At the cost, not only the cost of financial, obviously, but the cost of servicing it. Let's have a look here. For example, if we do that here on this particular detail, if we're just gonna hide, if we're gonna hide the frame behind the brick, I must apologize, something happened here. If we are going to hide the brick, hide the frame behind the brick, we will not be able to service it the way we necessarily want to. So if we are we would conceal that mullion in here, we would no longer be able to service that glass from the outside. And if we need to change the glass or clean it or do whatever, we would need to you know, do significant amount of work internally to actually get to that frame in here. So it is possible to conceal it. In this particular detail, the frame is visible, and we then can service that glass. We can replace it. Once you start concealing the glass and the frame behind the brick, so if you would go like that here, so if you can conceal it here, you would no longer be able to replace it. So that would be the main kind of, as I call, cost. Obviously, it's going to be more expensive, but not only expensive, it's also will be less practical in the future to service it. And again, thermal performance for precast, for example, and for masonry could be compromised, and there's a slight fire issue. It is possible if it's a significant element, but there would be implications. It is possible.
Great, thank you. There is, I think, Joe, who originally asked the question about the slip companies, has just asked if you can clarify them. So do you mind just running over those again, please?
It is called a Stowfix, Corium. I'll just hold on a second. I'm just gonna take a snapshot from the screen. I'm just gonna just do text Stowfix, and then sorry, I'm gonna write it on the screen here.
No worries, thank you.
Fix. Why doesn't it? I must apologize. I haven't done the presentations for a long time, and I'm a bit rusty. And mesh clip, I think, by Ash and Lacey. I would just say that mesh clip is a product by Ash and Lacey. So that product, yeah.
Okay, I've got all the links, so I'll share them in the group in a second.
Yeah.
Thank you for that, Joe. Hopefully, when I provide the links, everyone should get that. We've got a question in from Liz. Kindly please clarify the unitized system which you recommend for high-rise buildings. Is it bricks fixed on a metal framework, for example?
Right. Unitized system would be so that what you see on the screen now. I'm just going to expand it here, so it's more visible. So it's not unitized system. Unitized system itself. Go away. So this is unitized system. In this particular profile could be whatever the unitized facade is. So this could be Schuko, Aluke, Reynars, Veneer, whatever the thing is, and that only serves as a backing structure. Now, to this backing structure, to that unitized system, one could install any brick slip system that I just mentioned. This particular one that you see on the screen right now is Corium. This is Corium brick slip system that is fixed to the unitized system of the curtain wall. So in this case, unitized aluminum frame that is hooked on the building carries the brick slip system fixed to it. This particular one is shown as to be Corium, but that can be, again, it can be Stowfix, it could be mesh clip, and all of these three systems have done the unitized assemblies in the past. So I would not say that one's better than the other. They are all slightly different, but as far as I know, all three should be compliant with most of the requirements in the UK, with most of the requirements by the buildings in the UK.
Thank you. I've got a question in from Duncan. Is there a wide range of colors available for the precast systems as a standard, or does this come at a premium?
All of the, I would say that brick slips, it will be the cost of the brick slips. So that's for the precast concrete itself. If it's without brick. One thing I haven't covered in my talk, and I've seen that happen before, is when I was not involved in the project, but what the architect did and the contractor did, that they haven't they haven't cast in the brick in the precast concrete itself. They've done the pattern, the brick pattern, as a part of the mold. So the concrete had mixtures. It was colored. So the concrete itself was a certain color, and it was poured in the mold that had a shape of the bricks kind of cast in there. So that's what they were using to have that smooth, glazed kind of looking white brick texture, but that was just purely concrete with a smooth finish. And that would come at the cost, but still that would be far cheaper than using the cast-in brick. To cast brick into the precast concrete panel would depend on the cost of actual brick slip itself, because it needs to be a certain shape. as you can see here, to get the key to be able to get to be able to be held in place within the precast concrete. So that will be the cost will be in the type of brick itself rather than the color of the concrete. But as I said, there was an example when the brick texture was achieved with the mold. But other than that, there's no impact on cost for color of the brick for precast concrete.
Thank you. We've got a question in from Sean, and I'll ask a final question following that. So Sean asked, can a sawtooth bond be incorporated into precast components?
Yes, definitely.
Okay, great. And then my question is twofold. I know we previously discussed this, but for the benefit of everyone that's on the talk, could you explain the complexity of facade design, particularly from a fire perspective, and then also dew point perspective, when obviously you're dealing with varying requirements, not only from a technical perspective, but also from a cost and client perspective / contractor perspective, and how that adds additional complexity and it requires detailed analysis at every sort of stage.
For these buildings, for brick, I've done actually a presentation on that about a year ago for contractor for it's a wider topic, and I kind of was campaigning for having a precast concrete as the best way of achieving compliance, and I explained why that is. Because when you're dealing with the precast concrete, usually you're in hands of one contractor. In that case, one contractor is dealing with everything that happens with the facade. So they're responsible for placing the window within the precast concrete panel. Then they are actually creating in the position and do all the fire and all the other, for example, dew point calculations and everything else. And that becomes a very easy thing to manage, especially when it comes to the fully prefabricated precast concrete buildings. This would be the ideal facade engineering element. When you have a precast concrete building, not the facade, the building is precast concrete, when it's basically the facade is built out of sandwich panels, as you see here. The dew point line is here. It's constantly within the insulation. There is no issues with condensation anywhere, and there is no cavities anywhere, and there is no combustible materials anywhere. So when you have a precast concrete panels, prefabricated elements, sandwich panels, this would be the breeze for facade engineering, facade engineer on a project, for architects on a project, because everything is straight away figured out. However, that comes at the price of not having the flexibility of the design. So whatever the contractor can provide, and that will be very repetitive building. It would be a panel building. There will be lots of restrictions, and it will look as it's panelized, and you have to be very creative with creating recesses and changing the pattern of the brick to conceal that panelized nature of the building. But from fire perspective, and from thermal perspective and achieving compliance, a precast concrete sandwich panel building would be, in my opinion, the easiest one to deal with all of the elements. For other projects, you will be dealing with 3 different contractors. For example, for traditional masonry, we're going to get a glazing contractor that will be positioning the window in one location, and you would have a precast concrete contractor, the rain screen contractor to do another thing, and you will need to assemble it all together, run the dew point calculations, and get the fire engineer to verify that their cavity is compartmentalized properly, etc., etc., etc. Whereas with the precast concrete prefabricated building, everything is done by one contractor, and you are talking to one person. So I would prefer to have building like that you see on the screen now as the as the for compliance purposes for fire and the thermal.
Okay, great. We've got one question in last minute, so I'll quickly ask that and then I'll go
Sure.
to wrapping up the talk. This question in from Brian. Can brick slips suffer from efflorescence, and which part of the rain screen system is the water barrier, and how does this drain over windows?
It all depends on the project, I would say, but for the brick slip, it would be just for the brick slip system. The brick slip itself is a rain screen. It doesn't. I wouldn't necessarily count as like this is a rain or weather defense. So I would assume that the element, the sheeting board with EPDM would be the ultimate seal for the building, and vapor control layer would be here as a normal rain screen assembly. So brick slips is effectively a rain screen, the way I see it. I mean, one can just classify it as something else and use it as something else, but this particular detail shows it as a rain screen assembly, and is drained and ventilated as, let's say, that would be a standard aluminium cladding. That's how I would see it. So I would not see brick slips cladding used in this detail any different to aluminium cladding or let's say terracotta cladding or any type of rain screen cladding. So that would be, I would treat it exactly the same as just a veneer of the facade, and everything else performance-wise would be treated as a aluminium cladding building. So I'm not sure if that answered the questions, but yeah.
Okay, great. Thank you for that, Eugene. I'm just going to take over and share my screen. Okay, I hope that poster is visible. So thank you from Sai at Wessex for presenting today. And that, obviously this was Eugene Korch from Eugene Korch and Co, who's presenting contemporary brick facades. Really interesting analysis of a variety of potential options in regards to building precast concrete, prefabricated / offsite options, as well as looking at brick slips and also traditional masonry construction. So really interesting, and hopefully everyone's sort of gone away with a little bit of extra information on this subject. Moving forward, on Wednesday, 22nd of June, we have our next CPD, which is on neighbourly matters. So this is right to light, party wall, boundary disputes, etc. This is from a specialist in the area, so please do recommend for you to all sign up and attend that talk. We do have a joint event, which is a face-to-face event at Bristol Golf Club with CIOB, where we will have a speaker from the HSC who will be speaking about relevant issues that are highlighted in the current state of affairs that we have in the industry. So please do recommend you attending this one. Then back to our CPD in 43 schedule for July, we have a UK BIM framework presentation from Dan Rossiter, who is a specialist in that area. Again, I do recommend you to sign up once that's released. Here's another one, which is a collaboration between RIBA and CIET Wessex, where this is a face-to-face event which we've yet to advertise. So this is a special highlight in regard to getting in gear for a carbon-ready future. We're going to have a panel of speakers. There's a limited ticket, so please do, once it's released, please do sign up as quickly as possible. And then going back to CPD in the 43 schedule, our August event is from a flood risk specialist, AGIA, which is flood risk screening for schemes. We've got our September event, which is from Kine Mineral Paints, which is a specialist in paint application, so very specific paints for listed buildings, breathable requirements, etc. So very interesting there. In September as well, we've yet to advertise and produce a poster for that, but we do have a security event in Bristol, which is face-to-face. Again, once released, we do recommend that you sign up. Last time we held this event, we sold out over 80 in attendance on that day. Really interesting talk, so please do attend and sign up for that, and I look forward to seeing you all at our future events, or again face to face in due course. So that's it from me and Eugene from Science Wessex. So hope you all have a great rest of the day, and I look forward to seeing you all soon.